happy spring. I hope it's spring for you. It's sure spring down here in Santa Marta. And Hugh and I are actively learning Spanish. And just a fun fact, we got taken to the market yesterday morning and we're taught vegetables in Spanish. So we're very elementary in our Spanish and having a great time as we have sailed across the Caribbean, and now we're on the western part of the Caribbean and having a great time. And so I want to welcome you this evening to our third weather event with Alex Avalos, and Alex and I are both on now. And I want to, again, there are a lot of people who have been with us for all three events, and I really, truly appreciate that. And I really want to acknowledge you for being willing to come back and know that there's more to learn, that each time that you're here, that you're opening up and having the opportunity to learn more and more about this thing that we call weather that gets in our way when we're out here. And so I just want to take a minute and let's see if we can get this slide to advance. And of course, challenge me tonight. There we go. There, and just again, I want to welcome everyone. And I'm Captain Deb Marlar, and I am the owner and captain of Sailing and Boating LLC.com, which is my company that I started in 2021 after I had basically run the company under my other company, which is Simplicity Coaching. And so I really felt that with the courses that we were providing, that it was important to divide it out. And we have, I now have two companies. One of the first things that we're going to do this evening is we are going to do a poll, and I want to get a good sampling from everyone. So if you all, I'll want to turn it on here in a few minutes. We will have you all take a few minutes to go ahead and answer the questions. There are only 7 questions, and they're really, really simple. And we're going to go through weather basics again, but the biggest thing that I want to talk to you about is that we've left a good amount of time, and Alex and I spent a great deal of time last week talking about when we're on the water and we're seeing changes and feeling changes. How do we experience it, and what should we be expecting? And it's so important for us to know that. And so we're really going to spend some good time talking about that this evening. And so as you prepare for this evening, make sure that you have something to drink, something to write with, and a journal. And I hope you enjoy the evening. Go ahead, take it away, Alex.
All right. Well, first and foremost, I want to thank each of you for being here. Certainly Deb and Hugh are incredible and phenomenal people to be working with. And I'm really grateful, for the opportunity to be here with them today, and being able to share my knowledge in the field and, certainly fuel some more learning and any curiosity you might have about weather. The goal is that you come away from this discussion tonight with learning more than you had before. So without further ado, let's go ahead and take a look at the presentation that we're going to be discussing tonight. So we're going to be talking about, general weather basics, basically getting you up to speed on certain weather features, how to interpret various forms of weather data, also using various resources, including the weather provider. I'm also going to give you some examples of what you might see in the event of approaching unfavorable weather, what that can be a sign of, and also go over certain instances and examples of what would be normal out on the water on a given day and what kind of weather features you would want to see to have the best experience out on the water possible. So a little bit about me very briefly. I graduated from Lyndon State College in Vermont in 2014. It's now known as Vermont State University. Now I work at Weather Routing. I've been here for 7 years and I'm an operations manager today. I do have some experience with local sailing on a local lake here. That experience that I've had has certainly aided my knowledge in forecasting for sailing vessels. And certainly, they are a different they're a different beast, for lack of a better term, in that, you know, you certainly want to have the wind to sail. But of course, there's limitations to that even. You know, you wouldn't want to be out in significantly rough weather either. So the company that I work for, Weather Routing Incorporated, we're based in Glens Falls, New York, which is about an hour north of Albany, in the greater Lake George, Saratoga Springs region. We were founded in 1961 by a gentleman named Bill Kasich, and originally our company had opened in an office in Manhattan. And over the years, we've worked our way up the Hudson River to now be in Glens Falls. And we specialize in a variety of forecasting and routing for many types of vessels. As it pertains to the division I work in, the yacht division, we specialize primarily in sailing yachts, motor yachts, sport fishers and catamarans. We also forecast for jet yachts. We do forecasting for marinas, forecasts for rallies and regattas. And so those are just an array of the vessels that we provide services for. And we do provide specialized reports such as climatology studies to assess the feasibility of making a trip from point A to point B at any given point in the year. So looking ahead to some of the topics that we're going to be talking about today, we're going to be talking about weather and climate and the differences between the two. As Deb had mentioned in her opening, we're also going to be talking about interpreting surface charts as well as surface analyses, being able to interpret observations and how they can allow you to construct a basic weather forecast to understand what has happened and what could be coming down the pike, especially in the nearer term. We're going to go over radar and satellite data, as well as cloud progression, and how you can use the clues with the clouds to determine what kind of weather might be on the way. Some other topics we're going to be talking about, ocean currents. We'll be talking about what you should consider when planning a trip from point A to point B, and that can, you know, depend on, that could range from either a local trip or a longer offshore transit, and how you can best be prepared to handle what might come your way in terms of rough weather. I'll go over a couple of example trouble areas, primarily in the United States, that are common transiting regions, but certainly without proper planning, they can be proved to be problematic for any onward prospects across those regions. So I'll go over a little bit about what's more common in those areas, what would be normal in those areas on a given day, and what would give you the hint that inclement weather might be approaching and you would need to consider bailing off the water. We'll then go into a little bit more detail about the various weather sources that do exist, from a weather router to computer-generated weather apps, and we'll go over the pros and cons of those. We'll go over, again, a little bit more about local sailing versus offshore sailing, and how WRI can come in and assist you with that. At the end, we'll go ahead and talk about our supplemental service called seaweather.net. So let's go ahead and get into to the details, shall we? So what drives all weather on planet Earth? Well, it's that big orange fiery ball in the sky called the sun. You know, certainly 93 million miles away, but it certainly does not take a back row seat to generating or affecting the weather on the planet Earth. And the way that it affects the weather is that it causes uneven surface heating. You get the shortwave radiation that migrates towards Earth. And because the Earth is round in a sphere, the radiation is very uneven from the equator to the poles. So the equator, as you know, is in a direct alignment with the sun. The poles are very indirectly aligned with the sun, and thus they're not getting the most direct radiation. So what does that mean? Well, it transfers into heat at the equator and less heat at the poles. But you have a phenomena that happens once the shortwave radiation does hit planet Earth. You get the heat that basically is redistributed toward the poles, but at the same time, the cooler air that is located at the poles tends to migrate equatorward. So when you have this boundary or this convergence of the cool air and the warmer, moist air, you get rise to what are known as air masses. And basically, air masses can take a variety of forms. Certainly those that arise closer to the equator and in tropical regions will be filled with moisture. And certainly are warmer air masses than their counterparts across the Arctic and the Canadian Maritimes. Further north, you tend to get drier, cooler air masses. And when you have these air masses that are converging with each other, you get cold fronts and warm fronts. And basically these fronts are what drive our weather. So basically, kind of moving on from that first point there that I just made, the collisions of these air masses produces the fronts and then the resulting storms or inclement weather that can develop with their development. And certainly the larger the difference, meaning the larger the temperature gradient on either side of the front, it'll mean that the front is actually quite a bit stronger. Certainly the smaller the difference, the weaker the front. And our weather is governed by movement into and out of these air masses, which is led by these cold front and warm front passages. So briefly, climate is basically the measurement of average weather over a very prolonged period of time. And these averages really add up over the years. There's 5 different classifications, from the equator to the poles. Certainly, as you can infer, the closer to the equator that you are, the warmer and more tropical the climate temperatures or the temperatures over the climatology period are going to be warmer. Closer to the poles, they're going to be colder. And it's generally a gradual decrease away from the equator in terms of average temperature over a period of time. So these climate subcategories range from equatorial, as explained by the fact that it's located near the equator. And then the B climate subcategory is arid, C is warm, D is snow, E is polar. So you get the idea. The further away from the equator, the cooler the general climate has been over a given location. But weather tends to focus more on the here and now, and in the nearer term, like over the course of the next 1 to 2 weeks. But generally speaking, once you get out longer than that, and even a month or longer, you're generally looking at climatological averages. So surface charts are very useful in constructing a self-weather briefing. Having an understanding of what you can find on a surface chart can ultimately aid in understanding what the weather is doing and what you can expect it to do over a given period of time. So some of the features that you will have on a surface analysis can range from areas of high and low pressure, as well as cold and warm fronts. You can even spot troughs and tropical systems. So I will go into a bit more detail in this discussion about some of the weather that you can see with these weather features that would be in place in a given area. So let's take a look at an example of a surface front. Here you can see this one is quite busy, and that there's very active weather going on across North America in a number of locations, ranging from a gale in the Hudson Bay, and then a cold front extending across the northern high plains and upper Midwest, and a warm front extending across Quebec and into far northern upstate New York. You can see also a front draped across the southeastern US, with areas of low pressure also shown, high pressure, and then also a trough as indicated by this brown dashed line. So areas of high pressure, it's generally a given that with areas of high pressure, it's associated with calm weather, generally benign. Some of the things that you would see in an area if you were sailing with a high pressure in place, you might see very minimal cloud cover. If there's any cloud cover to be had, it would be in the form of cirrus clouds. If you're in the center of high pressure, that means that you're likely not going to be seeing much in the way of winds. For areas of high pressure, they tend to rotate clockwise in the northern hemisphere, or as we say in meteorological speak, anticyclonic. They tend to be semi-permanent and don't really move much. A classic example of that is the subtropical ridge in the Atlantic. So, there's a bit of a trade-off, especially for sailing vessels. Generally being in the center of a high, that's going to be the best bet to get the benign weather. But when you have the benign weather, you're not really getting the wind. So as unfavorable as that is, that's a telltale sign that you're in the midst of a large area of high pressure. Now, you can begin to see the winds increase closer to areas of stronger ridging, which expand outward from the high. As you can see, higher winds tend to occur on the edge or within the ridge, away from the high center. So a key assumption you can infer when you're out on the water is that, if you're not seeing much in the way of cloud cover, but the winds are increasing, a couple of things can be happening here. Either A, you're just happen to be centered right within the ridge and you're getting the wind. If a cold front has passed through already, the ridge will be building in behind it. And in that case, more likely than not, in the wake of the front, the winds are going to be generally out of the north. So closer to the center, less wind in place. Further away from the center, more wind will likely be in place, but you're not really seeing any indication of any inclement weather on the horizon. So here's an example of an area of high pressure centered over south central Quebec, and a ridge is extending into northern New England, down from New York and into the Chesapeake Bay area. So you can definitely infer here that for a vessel that's going to be out on the water in New England or the mid-Atlantic, it's likely going to have a pretty favorable day of weather. This is especially the case in New England, which is further away from the trough, which can also indicate rainfall. I'll go into a bit more detail about that in the coming slides. You'll note as well really quickly that the isobars do contract with westward extent across western Quebec and into central Ontario. So the winds there are likely going to be a bit stronger. So while the area of high pressure is the signal for benign weather, areas of low pressure tend to indicate the opposite. And where you get, the isobars becoming, where the weather is calmest near the center, it tends to be less calm away from the center. Generally, with areas of low pressure, it's stormiest and most unsettled near the center. And closer to an area of low pressure, you're not really going to see much in the way of squall lines. You're going to see more of heavy rainfall, even nimbostratus clouds. You may even get some wind too. It all depends on how strong or how deep the low is. And certainly the deeper it is, the more intense it's going to be, the more likely you are to encounter stronger winds. So certainly, in advance of an approaching area of low pressure, the weather is going to become unsettled really quickly. And certainly an indication that an area of low pressure would be approaching you is that the winds are going to generally be, depending on where you are with respect to the low. If you're on the south side of it, you're generally going to see south to southwesterly winds. If you're on the east and northeast side of it, for example, you're likely going to see southeast to easterly winds. On the west side of it, they're going to be north to northeasterly. And that's generally an indication that the weather should be improving behind it. But generally speaking, when you see an area of low pressure, you're going to be having unsettled weather conditions. And you can get thunderstorms to develop along a front that can extend from an area of low pressure. So I would say nimbostratus clouds tend to be most common with areas of low pressure and closer to the low pressure centers. They rotate counterclockwise in the northern hemisphere, or cyclonic, as we say in meteorological speak. Now in the southern hemisphere, they rotate clockwise. And I should have mentioned this earlier about areas of high pressure. They rotate counterclockwise in the southern hemisphere. So here's an example of an area of low pressure across the lower Mississippi Valley. You can see, as indicated and denoted by these green hashed lines, that indicates there's expected rainfall and even thunderstorms in these areas. We'll go into a little bit more detail about what this area between a cold front and a warm front is. Just to give you an idea of what the name of that is, it's called a warm sector. But generally speaking, anywhere in advance of an area of low pressure, it's very likely you're going to see unsettled weather. So cold fronts often produce the sharpest difference or sharpest changes between one air mass to the next. Depending where you are and what time of year, these can be more common across Florida and the Bahamas during the northern hemisphere winter months. As you head into the spring and summer, this cold front track begins to shift northward. So cold fronts, definitely you have to be mindful of those during the winter months in Florida and the Bahamas, as I said. As we get into the spring and summer, areas further north, such as the Chesapeake, New England, even the Great Lakes region, you have to be mindful that these are going to be more frequent. And with them, you can be looking at some pretty volatile weather, especially the stronger the front. Showery and squally weather is very common with these. On a hot summer day, you can certainly see development of cumulus and cumulonimbus clouds ahead of them. Certainly, the more widespread that they are, the more likely it is to be in the form of a cold front passage. That's not to say you can't get cumulonimbus clouds without a front nearby, but they're more likely to be widespread in the presence or the approach of a front. So if you're out on the water and you notice that the winds are veering from a southerly direction, but then they begin to gradually turn more to the west and northwest, that means that a front is moving overhead and eventually will be passing out of your location. And the winds at that point can tend to shift more northwesterly to northerly. So certainly if you have strengthening southerly winds and the combination of cumulus or cumulonimbus clouds on a hot summer day, along the northeastern US or the mid-Atlantic, or if it's earlier in the year, further to the south, like across Florida and the Bahamas, these are going to be clues that, certainly heavier weather is going to be imminent in those locations. And certainly having the preparation to, if you do have the option to have Doppler radar, that certainly works to your benefit. But certainly a good rule of thumb is if you do see bubbling up cumulonimbus clouds to your west, that's the front's going to be approaching in the not too distant future. So these fronts tend to move in the direction that the triangles indicate. The triangles are pointing in the direction the front is going to be moving. And so they usually move from northwest to southeast, basically ushering in a cooler, drier air mass that's replacing a warmer, moist air mass. And here's an example of a cold front extending from a low over New York City across the Delmarva and into the southeastern US. That front is moving generally southeastward. An example, the cold front counterparts include warm fronts. Basically where with a cold front, a cooler, drier air mass is going to be overspreading a warmer, more moist air mass. The opposite kind of happens with warm fronts. The warm fronts generally do not produce the same type of severe weather that a cold front would produce. But you generally would see altostratus and nimbostratus clouds becoming more common with warm fronts. Generally higher overcast conditions. Basically, a warm front is the leading edge of warm air overspreading a colder air mass. This warmer air mass tends to be more tropical in nature. Hence, the humidity will also increase with the front's passage. And the reason why this happens is because the winds veer from a more northeasterly direction to gradually east to southeasterly, where it's basically allowing warmer, more moist air to transport into a given region. So unlike with cold fronts, you're not really going to see much in the way of high winds. They're not uncommon, but they're not, it's not a regular occurrence. Certainly higher winds are something you have to be prepared for with cold front passages. And it's even more so the case when you have stronger ridging that's, being replaced by these front passages. But with a warm front, generally the semicircle indicates the movement of direction. And in this case, this front is moving north to northwest. So here you're going to have the leading edge of unsettled weather moving across the northern Appalachians and ultimately into New York, and then eventually into New England. So for a boater that's going to be out in the Gulf of Maine, over the next 24 hours, ideally they're going to be wanting to check the surface analyses and the weather forecast, because unsettled weather is going to be moving in. It's not necessarily as much a situation where with rain you would want to get off the water, but it's certainly something to be mindful of. If you have anything out in the open that needs to be brought in to keep it dry, these are logistics to consider. when you have a warm front, for example, that's going to be moving across a given location. Now, stationary fronts are basically the combination of a warm front and a cold front basically converging. The reason why they're stationary is because, as you can see in this example here, the triangles are pointing southward and the semicircles are pointing northward. They really can't move anywhere. They're kind of stuck in place. So with a stationary front, generally speaking, you will expect to see rainfall persisting in a given location over a more prolonged period of time until the front washes out. But that's the bad news. The good news is that you don't really expect to see any strong winds in association with a warm stationary front passage, nor are thunderstorms all that common either. It's mainly a focus for rain. And so here's an example of a stationary front extending across the great state of Kansas, and then westward into Colorado. You can see that there's a warm front trying to lift northward and a cold front trying to push southeastward, basically showing that the front's not going to be moving anywhere. So you could definitely see that in this area, there's steady rainfall ongoing, not really much in the way of thunderstorms. Any thunderstorms that would be occurring in this example would likely be occurring on this brown front here, which is called a dry line. It's a very common weather phenomena in the Central Plains, down into Texas, which basically is a moisture boundary. So occluded fronts basically do the opposite, well, kind of do the opposite, I should say, of what a stationary front does. So a stationary front occurs when a warm front and a cold front collide, but an occluded front develops when a cold front basically is moving faster than a warm front. So basically, when you have a cold front overtaking a warm front, basically warmer air with the front is pushed aloft because it's less dense. And then basically the air becomes cooler with the warmer air mixing in. So it's basically a shift from a colder air mass to a less cold air mass because of the warm air that's replacing it. And then the triangles and circles indicate the direction of movement with these occluded fronts. And you can see this example is showing the occluded front moving generally northward. And here's an example of an occluded front off of Cape Cod, extending southward to the offshore waters of the mid-Atlantic. And basically this occluded front resulted from this stronger cold front overtaking this warm front that extends northward and eastward over Bermuda, or to the north of Bermuda. It's basically a hybrid between the two. So we talked about cold fronts earlier and how they're the transition from warm, moist air masses to cooler air masses and wind shifts. Troughs do serve a similar purpose to fronts and cause similar conditions, but there's a notable difference between troughs and cold fronts. Troughs are primarily associated with wind shifts. They're not associated with temperature changes. And as a result, it's unlikely that you're going to get the same severe weather concerns that you would get with a cold front. If you're out on the open water and then all of a sudden it starts raining, you don't really get much in the way of thunder, but then you notice a wind shift occurring at that time. That means that a trough is likely shifted overhead, which can also be a warning that a cold front is imminent within the next several hours. And so a more dramatic wind shift and temperature change would be in order in that case. One thing that a trough can do is when it does allow for showery weather ahead of these fronts is that, any lingering cloud cover that can result from troughs, will ultimately help to stabilize the atmosphere, or at least minimize the window which the atmosphere has time to re-destabilize to prevent severe weather down the road when a cold front passes through. So here's an example of a trough on the map in the wake of that front that I told you about before, and they can still occur in the wake of fronts as well. But it's very common that you tend to see them ahead of fronts more so than behind them. And you can see that example is here in this image across central Quebec, ahead of that next front that's moving through. Excuse me. So moving on from surface analyses, we also do take a look at upper level analyses to basically get an idea of what's driving the development of fronts and lows as well as highs. The same philosophy applies to upper level wind patterns that applies with surface analyses, in that whenever you see a large digging trough, that indicates that there's inclement weather on the way. So I know most probably don't look at upper level analyses in their weather briefings, but anytime that you do see a trough, you can automatically assume there's going to be some kind of unsettled weather in a given location at a given time. You can see here there's a large blocking ridge out in the western half of the country, which is associated with benign weather and favorable conditions. Excuse me, I apologize. So here you can see that upper level trough across the eastern United States. Kind of pivoting to understanding wind barbs and what those entail. It can be very easy to get confused between wind barbs and wind vectors. They both tell similar stories. However, there's a different interpretation to the two that you need to be aware of to fully understand what they're communicating. So, for example, a wind barb tells you the direction the wind is coming from, and it's pointing in that direction. With a wind vector, basically what it's saying is that the wind is coming from a certain direction and headed in that direction. So they're not exactly showing the same information, but they get the same point across, if that makes sense. With a wind barb, you can see here a full barb indicates 10 knots of wind. A half a barb indicates 5 knots. When you add the two together, you get 15 knots. Pretty self-explanatory. If you convert that over to miles per hour, that works out to 17 miles per hour. And whenever you see a flag on a wind barb, that indicates 50 knots of wind or 58 miles per hour. In this example, it's pointing southward, so the wind is coming out of the south at 50 knots or 58 miles per hour. You can see if this wind barb, it's pointing to the southeast, which indicates the wind's coming from the southeast. You get the flag, which is 50 knots, 10 knots for a full barb, that makes 60, another 10, that makes 70, and then a half barb, that's 75 or 86 miles per hour. So the key takeaway from wind barbs is they communicate the direction the wind is coming from. You're going to see wind barbs on some surface analyses as opposed to wind vectors. This would be the most common method of communication for wind direction and speed. So the Beaufort scale, in a way, is kind of a tale as old as time, if you will. Before there were notable instruments available to measure wind speed or to measure wave heights. Basically the Beaufort scale existed based on what the naked eye was showing to a sailor. So it ranges anywhere from force 0, which is basically as benign and calm as can be, to force 12, which is the most volatile and dangerous. There's a wider range of conditions that one can use the Beaufort scale to determine what the wind speeds are, which can then, in effect, tell you what the estimated sea height might be. So another meaningful tool that can be very helpful to mariners, who may not have a radar, and I do realize this is an older method of measuring changes in pressure, but if you're out on the water and you do see that the pressure is dropping, that's an indication that an area of low pressure or a front might be approaching at some point in the near future. At which point you can then determine how quickly the pressure is dropping. Smaller changes in pressure, not really cause for alarm, but they're enough to make you aware that weather's going to be changing in the not too distant future, and to act and prepare accordingly. If you see more significant drops in pressure, in a short period of time, then that's a significant clue that the weather's deteriorating. Would be a good indicator that you would need to get off the water as soon as possible, because some of the changes that might be approaching include a strong front, perhaps strong thunderstorms and squalls, stronger southwesterly winds ahead of a front that could be filling in. Basically, anything that indicates a drop in pressure is something to be aware of for changes in weather for the worst. Now, for buoy reports, these are very useful tools for getting an idea of trends over a given location. They communicate some very useful tips for anyone who's reviewing them. The National Data Buoy Center has a very good database of these. Basically, they tell you what the time is, the date, and they give you the wind and the wind gust at that given time, as well as what the wave heights might be in terms of the dominant wave period, the average wave period, the direction the waves are coming from. They'll also tell you pressure, so that can give you a clue as to whether the weather is holding steady, improving, or declining. So in this example, at least just by reading the observation, you can infer that the weather will be improving. However, it's important to look at a wide arrangement of obs in a given location to get a general idea of what's happening in the greater area, because one ob on its own won't tell you a whole lot, but getting a general consensus can give you a lot more information as well. So the buoy data is quality controlled, so it's updated in any erroneous data that could be present. For example, if it's an area of high pressure and it's showing wave heights of 12 feet and 50-mile-per-hour winds, 50-knot winds, then it's probably erroneous. And that can be confirmed by other obs in the area if that's the case. But those kind of obs are generally kept in check by the National Data and Buoy Center. And you can look at an archive of recorded observations at a given buoy to basically give you an idea as to what the weather's done over a given period of time. So it's definitely a very useful tool for a sailor who's ready to go out on the water to just kind of get an evaluation of the trends. You can see in this example, there's really not a lot that sticks out as a red flag, in terms of being able to get on the water and have a good day there. You can see winds generally have averaged between 13 to 17 knots for the better part of this 24-hour window. And then so because of that, you can also take a look at what the pressure has done over this time period as well. And it hasn't really changed all that much. So you could basically conclude, at least based on this ob alone, that the weather really isn't changing for the worse. It's not really changing for the better either, but it's not changing for the worse. And certainly looking at the wave heights combined with the winds, it does look to be a fairly decent day to be out on the water. So definitely, briefing yourself on the ongoing weather before heading out on the water will, only benefit you as opposed to hinder you. Other forms of observations that are not buoy related include ship observations. So unlike buoy data, these are not quality controlled. And a concern with these is these may not be placed in the most reasonable location on board a vessel. So if they're located on the mast, which is higher up, one of the most high up locations on a vessel, the winds are going to be higher there just based on, elevation, and nothing really to slow them down up there. So, you might have some erroneous data out there that's not really born in reality. So it's always good to take a look again at other surrounding observations to get an idea. Now, buoys tend to be located in one location. So you can more easily evaluate the trends in those areas over a given period of time. Ships, however, because they're on the move, it's not exactly the most telling option to see what the trends are with the weather, because they might be moving out of an area of high pressure and further away from the front. it's not really all that indicative or as indicative of any significant changes in the weather versus a group of buoys that don't really move anywhere. But they do still communicate a lot of useful information, including the wind direction and speed, any waves that are of concern and the period on those. They also communicate the pressure. And if there's any visibility concerns, they will mention that, as well as the sea surface temperature and dew point. Another method of basically understanding what's happening in real time or as close to real time as possible is to take a look at the advanced scatterometer, or known as ASCAT. Basically, these are satellite-derived winds attained by a polar orbiting satellite. They measure wind direction and speed. These wind speeds are basically estimated on wind-driven seas in the areas beneath them. So the satellite uses those seas to generate, these wind derivations in these scat passes. There are limitations to this, however. As you can see in this example, the pass only goes over a given area twice a day. So there's generally holes that will take place in a given location, and you're going to be missing data in these areas. Now, this is a very useful tool for getting a general overview that buoys and ships can't tell you. But there's a limitation in that because it's run twice a day, you have to use it to evaluate trends. It's not always going to be up to date in the moment when you might need it. So that's something important to take into consideration. So for vessels, for any sailors that do have radar, certainly this is an incredible tool to take out on the water with you. This will tell you all the answers that you need for any approaching severe weather. Strongly encouraged if you can get access to that. That will make sure that'll help you be as well informed of any changing weather as possible, any approaching thunderstorms. And basically the radar does just that. It evaluates precipitation intensity. When you look at a standard radar shot, the cooler colors will tend to indicate lighter rainfall or precipitation, whereas the hotter colors will indicate thunderstorms and heavier rainfall. And you can see in this example, there are definitely a couple of examples of those. Offshore of southwestern Louisiana and southeastern Texas. And another thing too, thunderstorms can produce gusty winds. So that's something that, knowing where you are with respect to a thunderstorm will ultimately allow you to take the maneuvers needed to stay away from it, or at least get around it. Sometimes there are situations where that's unavoidable if it's a widespread thunderstorm complex, but that's also where it's important to have a full understanding of the forecast before going out on the water, so that you're well prepared for any widespread thunderstorm squall lines that might be problematic for any sailing experiences out on the water. So there's 160 radars all across the United States. The range on these radars is limited, so that speaks to why we have as many radars as we do. And usually there is some overlap between one radar to the next. So like in my example, Albany, New York is a radar location here. The next closest one is Burlington, Vermont. There is some overlay between our two radars to make sure that areas north of Albany are also getting radar coverage, as well as across the Adirondacks and into the Green Mountains of Vermont. Radars are also very useful not only for heavy rainfall or lighter rainfall and determining precipitation intensity. They are very good at identifying potential areas that could produce tornadoes or even water spouts. And the availability worldwide tends to be more limited than in the United States. I'm not sure what the concentration is offhand as to how many radars there are elsewhere in the world, but the greatest concentration of them occurs here in the United States and all related United States territories. So here is an example of a water spout or a tornado on radar. Certainly if you're out on the open water, you'd be able to see a water spout nearby. However, the concern can then turn to the fact that you might not have had ample warning that one of these is going to develop. And unfortunately, water spouts do develop with little to no warning sometimes. So another pro as to why having radar on hand is vital, because some of these situations can arise where you get these water spouts, that can be extremely dangerous, if not deadly, to boaters out on the water. And there's key signatures that you can find, that indicate that a water spout might be developing. And it's often shown in the form of a hook. That's what we call a supercell thunderstorm. On the hook of that supercell, or the comma, which is another name for it, that is likely where you're going to find the tornado or the water spout. So in this case, this supercell has not moved on shore yet. So if there's a water spout on the ground or over the open waters, it would likely be roughly here in this comma, but then it would transition into a tornado as it moves on shore. And radar has a handy tool called velocity that you can check to determine, what direction the winds are moving and what the wind speeds are. So to identify a water spout on radar, you're going to generally be looking at a couplet for two different colors. It looks like, in this example, you get dark blue on the west side, and then kind of like an orangish on the east side of it. And basically what happens is, because in the northern hemisphere, tornadoes tend to rotate cyclonic, or like this, counterclockwise. Basically what this is indicating is that the cooler colors are going towards the radar and the warmer colors are going away from the radar. So that causes that rotation. So if you're in an area where water spouts are a common concern, this is especially the case in a place like Florida, where water spouts are not all that uncommon. Having access to radar whenever thunderstorms develop is important. So you can see here that the arrow is pointing to where the water spout is most likely to be. So there's a variety of tools that help you to further understand cloud cover. There's pros and cons to each of those. The most common ones that are used include visible and infrared satellite imagery. You can also use water vapor imagery as well, which can help to identify troughs, digging, over a given location. Satellite imagery can be used to find fog banks as well as thunderstorms, and other weather features. And I'll go over exactly, what some of those weather features are, what type of satellite imagery you would need to use to best see that. You can also spot outflow boundaries on satellite imagery, which are basically like mini cold fronts, but they yield gusty winds. So visible satellite imagery is the most high resolution of the satellite imageries that you're going to find between that, infrared, and even water vapor imagery. Basically, visible is, as its name implies, you can see the clouds during the day. It's visible because of the sun. Visible satellite imagery is very useful to determining cloud shapes and characteristics. However, there is the unfortunate reality that you only have the availability of visible satellite imagery during the daylight hours. So while you get that high resolution, it's only available for more or less 12 hours out of the day. Excuse me. There are some good resources for visible satellite imagery, including NASA on the GHCC website. And as I alluded to, you can generally make out the shapes of the clouds, which can indicate thunderstorm development. Excuse me. So in this example, across the Lesser Antilles and the Southern Leeward Islands, you can see a cluster of clouds. There's some notable features that you can make out in here. Obviously, where you see these clusters of whiter clouds, that can indicate thunderstorm development. Where you see generally grayer cloud areas, that can indicate more uniform overcast cloud cover. Wherever you see these thin ribbons of clouds, that can indicate a gust front. So basically what happens is those propagate outward from the parent thunderstorms. and they move in a given direction with respect to the general movement of the thunderstorm. So you may be out on the water some days, and overhead it actually looks like a really nice day. But then all of a sudden you get blasted by winds coming from a given direction. You might ask, well, why is that happening? A thunderstorm may be located out in the distance, not necessarily near you, but these outflow boundaries can travel for miles. So when you see a thunderstorm in the distance, even though it's not directly on top of you, we always talk about how if you can hear thunder, chances are you're close enough to be struck by lightning. If you can see a thunderstorm off in the distance, you're not out of the woods where you wouldn't get hit by one of these gust fronts. And certainly, you're not getting the 1-2 punch where you're getting the thunderstorm overhead and then the gusty winds with it. You can still have very nice weather and still get whacked by one of these fronts. And you can see there's multiple ribbons on this imagery, extending from Barbados. I believe that's St. Lucia, and then westward. And then there's a couple more here north of Guyana, another thin ribbon extending here east of Trinidad and Tobago, and then working your way into the open waters across the Western Atlantic. So you can see the outflow boundary, like I said. Thunderstorms, as I said, very, very easy to spot in visible satellite imagery. Wherever you see the more popcorn appearance, that's where the cloud tops are likely to be tallest. And when you have tall cloud tops, you're going to get those thunderstorms. And then for visible satellite imagery, one of the last things that is wonderful, that visible satellite imagery is wonderful for our fog banks, being able to identify them. And they look a bit different than your typical cloud cover over a given location. Fog banks generally are grayer and smoother on satellite imagery. And let's say you're going sailing in New England over the course of the summer, you're going to find more instances of dense fog in the morning hours, and even during the early part of the afternoon. It's not out of the question either, especially in the Gulf of Maine. But this also happens across the Cape and Islands, and even across southern New England, across Long Island Sound. It's not uncommon either. And the reason for that is because of the temperatures. When you get the temperature changes, over land across New England, with it warming up during the spring and summer, but the very cold sea surface temperatures remain in the Gulf of Maine, and then also across southern New England. That presents the ingredients needed towards seeing more fog at that given time of year. All right, so moving on to infrared satellite imagery. This is a counterpart to visible satellite imagery, and it has its pros and cons versus visible. The biggest pro, of course, is that it's available at any hour of the day or night, whenever you need it. It'll be there, no questions asked. It measures cloud temperatures. So the way it does that is it takes stock into the overall cloud heights. And in the example that I'm going to show you, you'll see what I mean by that. However, because even though you have the 24/7 availability, the resolution is not as good as it is with visible satellite. So because of that, you can't see things like outflow boundaries or sea breezes, or sometimes you won't even be able to see gust fronts. So there definitely are limitations to this that you would not get with visible satellite imagery. So as I said, infrared satellite imagery shows cloud top heights. And as you can see by the legend here, the warmer the colors get, the taller the cloud cover, the taller the cloud tops are. So the taller the cloud tops are, the more likely you are to encounter thunderstorms. And in this example, you can see that, we've got thunderstorm development near Cozumel and Cancun, and then another one south of the Rio Grande Valley. So with cloud progression, this can help you to understand. It kind of ties into our discussion about changing weather patterns and knowing what to recognize when out on the water. Clouds tend to change ahead of systems, and they can give you the clues that you need to know, whether it's going to remain constant, like the weather's going to not change much for better or worse, or whether it's going to be changing for the worse over a given period of time. And, as that old cliche saying goes, red sky in the morning, sailors take warning, and red sky at night, sailors delight. So one of the most common forms of clouds that you can see during the summertime in particular across the Northern Hemisphere, but you can see these across Florida and the Bahamas and the Caribbean during the winter months. Cumulus clouds are an indicator of, limited moisture, but not moisture that's non-existent anyway. They usually can occur, or they can occur within a ridge of high pressure. But they can also be an indication of an approaching cold front. And, generally, the stronger the cold front, the more likely you are to get more instability ahead of the front. That can also trigger growing cumulus clouds, which then progress into cumulonimbus clouds. So whenever you see a cloud like this, whether it has an anvil or whether it has a very popcorn-esque appearance to it, those are both strong indications that a cumulonimbus cloud is producing a thunderstorm, and you're either going to have a cluster of thunderstorms or it could be a lone wolf situation. The most likely lone wolf situation you would encounter would be in the form of supercells, like that example I had showed you with the water spouts. But when you see these on a more widespread scale, if you're out on the water and looking west offshore of southeastern Florida, during the winter months, you're going to be looking at a front that's going to be moving eastward. And then, as far as how quickly the front is moving, if you can see these winds increasing at the same time while you're monitoring these clouds developing and growing, certainly you have inclement weather that's going to be heading your way within the next few hours. These can also be spotted in the summertime across Florida. But usually during the summer months, the cold front track progressing northward across the mid-Atlantic and New England, any cumulonimbus clouds that you encounter and experience across the southeastern U.S. are likely going to be in the form of sea breezes, especially across Florida. And these thunderstorms, when they do develop off a sea breeze, can meander offshore. For cirrus clouds, these are generally indicative of larger storm systems approaching a given area. The reason why they are an indicator of a storm approaching is because of moisture. And they will tend to increase in density over a period of time because of the approaching storm system. Usually the time frame in which you would see these clouds tends to be anywhere from 24 hours or less prior to the onset of stormy conditions. You can see these with the approach of a warm front passage ahead of the main system. So altocumulus clouds tend to be more common after cirrus cloud development. You tend to get lowering cloud bases with altocumulus clouds. And that's usually an indication that you're within 12 hours of the onset of stormy weather. Certainly they can also occur behind warm front passages after the main squeeze of rainfall has passed. But certainly that can be an indication as well of a cold front approaching from the west. Now, nimbostratus is basically indicating that it's game time, if you will. This usually means that precipitation is either right around the corner and imminent, or it's actually already occurring. Common concerns with nimbostratus clouds include fog and hence lower and reduced visibility. And you can even get heavy rainfall with these as well. But generally, an improvement in visibility also indicates that conditions in general are going to be improving. And one of the other clues that the weather is going to be improving is that the precipitation is decreasing in intensity. and overall coverage. So as that happens, the visibility will increase. Nimbostratus clouds will tend to shift out of a region, and you'll begin to see some decrease in cloud cover. One of the more important, well, I should say all of them are important, but one of the other important features for for a sailor to take into consideration are currents. Currents can really either be very helpful or they can be a real pain, if you will. So you all know, the Gulf Stream extends across the Florida Peninsula and into the Gulf of Mexico. That's one of the largest currents in the United States. So because it's such a large current, you don't really get a significant amount of variation with, with the Gulf Stream in terms of what the outer walls, the changes in the outer walls don't really occur very much, and they don't vary much, versus smaller tidal currents, for example, can be more influenced by the weather. And so another concern too with a larger current like the Gulf Stream, you can see, significant changes in current speed over a shorter distance. So here you have the Gulf Stream that's meandering northeastward from Cape Hatteras and staying generally to the south of New England and the mid-Atlantic. And it's basically a ribbon of warmer sea surface temperatures that meander into the open waters of the Western Atlantic. So there's some really nifty things that are showing up here on this image. You can see that there's a pair of eddies, which are basically rotating areas of stronger currents. Whenever you see them rotating clockwise, that's an indication of a warm eddy. So what's happening is warmer sea surface temperatures are being lifted northward and replacing cooler areas of sea surface temperatures. And the opposite is true for cold water eddies. They're basically colder sea surface temperatures are replacing warm sea surface temperatures, and they rotate in a counterclockwise fashion. And there's a smaller cold water eddy occurring here, closer to about 35 north, 68 west. And then another warm water eddy further east, closer to about 35 north, 60 west. But when you overlay the sea surface temperatures over a given area, and over this area in this example, you can really see the ribbon of warmer sea surface temperatures to the point that you can actually make out the Gulf Stream in this image. And you'll note the really significant drop off in temperatures north of 40 north, into southeastern New England. Even in Long Island, it's, Long Island Sound, it's still a notable decrease, but it's even more drastic heading further north into the Gulf of Maine, and then northeastward towards the Canadian Maritimes for areas that remain well to the north of the Gulf Stream. So you're talking about a temperature difference of about 84 degrees Fahrenheit around the 37 north, 67 west, and then you take it northward to about 44 north, you're looking at temperatures comfortably into the 50s. So you can get some really drastic changes in the sea surface temperature over, in the grand scheme of things, it's not a very significant distance, a few hundred miles. There's that drastic sea surface temperature change. It's even more remarkable because sea surface temperatures don't change as readily as air temperatures do. So as far as planning your trip goes, when you're considering the weather for a trip, it's always good to know your vessel through and through. I'm going to go into a bit more detail later in the discussion about working with a weather router and what we do to help you plan the most comfortable and safe transit. But before you plan on getting underway, it's always good to know the vessel through and through, what the vessel's capable of handling if you do get stuck into any heavy weather conditions, what you're willing to tolerate, consider the tolerances of everyone on board, what they're willing to, to encounter, and what you would like to shy away from. These are important considerations to take into that come into play when you're planning either a local trip or a longer offshore trip, where you're going to see more variability in the weather and a slightly larger unpredictability and less time to act. So basically, the questions that you should ask yourself when it comes to weather Do you feel comfortable handling rough weather on longer passages? Is the vessel ready to handle that? Having an understanding of common trouble areas for sailing is also very beneficial. And these trouble areas are not only limited to locations where weather is notoriously bad when bad weather strikes, but topography can also play a role too. So I'm going to go into a bit more detail about some of the more common areas that you're likely to encounter trouble with local effects. One of the most notorious locations on the East Coast is Cape Hatteras. For anyone who's sailed north or south of there, there can be varying degrees of trouble that can develop there. In the Bahamas, a common area is the tongue of the ocean and over the banks, but more so for the former of the two. Mona Pass is also another area that there can be trouble with northeasterly swell propagating in. Cape Mendocino and Point Conception over on the western United States coasts are also very common areas of concern. And certainly in a lot of these locations, the time of year can play a significant role as to what those effects are. So for Cape Hatteras, I showed in one of those previous slides, the Gulf Stream propagating northeastward. One of some of the concerns that you could expect to see that would require you to consider getting off the water, especially during the summer months, or the spring and summer months, I should say. You get those hotter summer days, and you can get a sea breeze to develop along the eastern Carolina mainland. So it's very common to see a wide array of cumulonimbus clouds developing during the heat of the day in the summer. And those can emanate eastward towards the coast off the Outer Banks and towards Hatteras. The concern around Hatteras is that you can get funneling conditions there. They're most enhanced when you get a cold front passage moving over these areas, or if you get a strong ridge. Local funneling is definitely an issue. But the reason why I post this image of the Gulf Stream here is because whenever you get a ridge building behind, a cold front, those winds tend to shift more to the northeast. And whenever you get that northeasterly wind over the counter current or the against current, you're going to have stacking of the seas. So not only are the winds going to be far from ideal, but the sea state is going to be far from ideal. And the sea state is also going to be short period. So it's not going to be a very pleasant experience for anybody who's out on the water. Just in broad speak, that's not taking into consideration the tolerances, because I know there's varying degrees of that in the sailing world. But generally speaking, taking a look at the weather, whenever you get winds out of the northeast, that's a good sign that you should consider being out of the water. If the wind's out of the southwest, that usually means that a cold front is approaching, and like we've discussed in previous slides, that can indicate thunderstorms are also on the horizon. But cold front passages tend to be more common during the spring and early summer months when the heat of the day is not driving those sea breeze developments in these areas. But nonetheless, it can result in inclement weather when you have a front approaching. So in the tongue of the ocean and over the Bahamas, the tongue of the ocean is this stretch of deeper water that runs from the Northeast Providence Channel down through, west of Nassau and then into the east of Andros Island. Because the water is deeper here than over the banks further to the east, you can get those larger seas propagating into the Northeast Providence Channel. And a lot of times in the wake of frontal passages, you can get longer period, albeit larger swell here. In the wintertime, a concern that often arises is the presence of, the Christmas trades starting in December. Those can persist for weeks. Because of that, you can get east to southeast winds that fill in over the central Bahamas and across the tongue of the ocean. That can result in the stacking of seas in these locations. If you have a larger gale that's passing well to the northeast, sometimes you can get longer period swell propagating in here, which by comparison is not as significant a concern, versus the sea state that you would encounter during the trades. So it's very common during the winter months in particular, and even into the spring months, that if you are going to be out in the water in the Bahamas and in the tongue of the ocean, that these are real concerns that you would have to plan for on any given day. Now, another concern, of course, during the winter months is cold front shifting off of Florida. You get winds shifting out of the south. That allows some pretty large fetch to develop, basically from the south end of Andros up towards Chub Cay and the Berry Islands. And that can result in some notably larger seas in this deeper pocket of tongue of the ocean. Seas will generally be less over the banks because they're shallower. And you don't really get the same building of the seas in shallower waters that you would in deeper waters, because that fetch tends to be larger in those areas. So if you're going to be, like I've said, if you're going to be out in the water in December, January, February across the Bahamas, keep in mind that your best experiences are likely going to be over the banks, where the sea state is not going to be as much of a concern. It's a great time of year for sailing, though, because the trades are pretty persistent, and that's going to provide ample opportunity to endeavor in that. But sailing is best when the seas are not really a significant concern. That can be a tall order to come by, especially in deeper waters, and that's why navigating over the banks would ultimately provide the most favorable experience. Now, kind of moving back over to the United States and over to the West Coast, Cape Mendocino is a very challenging location to get around. And this is especially the case during the summer months, when a thermal trough sets up along California. And it's a pretty extensive trough too. It extends all the way down to the Gulf of California, which basically extends to the east of the Baja. The reason why this thermal trough is a concern and resulting northwesterlies are an issue is because as we go through the summer months, the sea surface temperatures off of northwestern California don't really get that cold or warm, rather. However, California, during the summer months, many locales can get very hot. So the thermal trough is generated by that sharp difference in temperature over those two locations over a very small distance. So summertime is actually one of the worst times to try to maneuver around this location. Any planning for being on the water near Cape Mendocino, you would definitely want to plan on being local and closer to the coast. Best times of year to make any crossings around Cape Mendocino and at any point offshore of that location would be during the spring months, when it hasn't really warmed up, but you still get the cold fronts coming through to prevent any significant strengthening of a thermal trough. Plus, it's just generally weaker during the spring than it is during the summer, because those temperature gradients are smaller. But summertime, it's generally a very challenging portion of the year to maneuver very far offshore from Cape Mendocino, because this trough can persist for many days at a time with little change. And some of the northwesterly winds that wrap around Mendocino can be on the order of gale force. And if you're south of Mendocino, that can be a real problem trying to get north, because it'll be on the nose and in front of you. Another area on the West Coast along California is also Point Conception. Point Conception is another area that's notorious for funneling. And the summertime is also a challenging time of year to be able to get around here in lighter winds. But funneling around Point Conception is more common in the winter months than it is around Cape Mendocino in the winter months, largely owing to the fact it's further south. But when you get these northwesterly winds wrapping around Point Conception, they do tend to funnel into the Santa Barbara Channel. So let's say you're going to be out on the water in Santa Barbara or Ventura, or even Santa Monica. Generally speaking, whenever you see a strong northwesterly wind coming in, it's going to be weaker than it is at Point Conception. So any localized sailing that occurs, between that area, Point Conception, and the Channel Islands should be largely confined to areas closer to Santa Barbara and Ventura versus Point Conception, where you're going to encounter the brunt of the conditions. You're not really going to see much in the way of cloud cover or thunderstorm development there. So that's not really an issue in Southern California during the summer months. So for any local sailors in those areas, you don't really have to plan for that. But whenever those northwesterly winds get stronger, during the heat of the day, that's a good indicator of needing to get off the water. Though generally speaking, in the summertime, they can be unavoidable regardless. It's just about minimizing the strongest winds, which would tend to take place later in the day. So a little bit more about, your sources that are available to you. You'll want to consider a variety of things. Of course, you want to have a provider who's going to provide you the most accurate forecasts. That's going to be reliable. And by reliable, I don't mean only producing accurate forecasts, but are they available around the clock when you need them? With here at Weather Routing, we are a 24/7 operation, and we understand that sometimes weather-related situations do develop, and they can develop on short notice. So we recognize that, from clientele needs, someone, our team of meteorologists will always be available to answer any questions you have on short moments notice. So we strive to provide that for our clientele when they need us. There's also the need to understand the science of meteorology and to understand what might govern the weather in given areas of the world. For example, just tying in some of the locations we just talked about, what drives the weather near Cape Mendocino is not exactly going to be the same around Cape Hatteras. So there's different features at play here, and having the understanding of what governs the weather in those areas is crucially important. Accessibility, certainly the more availability they have during the day and even night, the better. If you do watch on-air news meteorologists, take a look at their knowledge of the general area that they're forecasting for, as that's very important because, like I said, weather's not governed in the same two exact ways in two different areas. So that's something to be mindful of. So some of the common computer sources, that are available include NOAA and a variety of mobile desktop apps. There's a variety of those such as Windy or Predict Wind. So they do provide you a wealth of information such as model data, but you don't really have that human element. And certainly there is a limiting factor to how accurate the models can be. And this ultimately depends on the time or the location in which you're reviewing this information. So some areas where models don't exactly do the best job of picking up on local effects include, Northern Hispaniola, Mediterranean, and where Deb is over in Colombia. The winds can really be underestimated by models. And so having that human element really allows you to get a better understanding of exactly how strong the winds are going to be. And, basically the human element comes from years of experience, and learning over the course of time to see, to understand how the terrain plays a role, and the temperature changes from land to ocean can really affect, the conditions in a given location, such as in Colombia or even Hispaniola. Kind of looping a little bit back towards what I talked about earlier for planning your trip, but kind of tying it into what we do. We strive to work with our clients to make sure they have a variety of options if they need them. We understand that, there are priorities to get from point A to point B. And we also understand at the same time the weather doesn't cooperate when you want it to. So we work hard with you to help you plan your trips, for bailout options if needed, to make sure that you're on the best route possible, to make sure that conditions are as favorable for sailing as possible, because we understand that, you want to have the wind to sail to minimize the need for motoring. But that also underscores the need and the importance for having an ample fuel supply if absolutely needed. Because sometimes the weather doesn't cooperate in the manner that you might have a longer trip that requires you to plainly motor. So you might need to even plan for fuel stops along the way from point A to point B. So we can assist you with all of that to make sure that you're getting the best window to sail, you're minimizing the stops if you need to, and you're minimizing your extent in the worst of the conditions. So our recommendations are largely driven by, the constraints that you provide us. So we take into consideration the tolerances of your boat and your crew. The golden rule number one is we want to get you there safely from point A to point B, but we do want you to be able to enjoy yourselves. It's certainly, life on the water is very much an adventure, and we want it to be a comfortable experience and as enjoyable as possible. So we work very closely with you to make sure that that happens as best as possible. So we do advise in a situation where it's just not viable to depart based on what you tell us for constraints and tolerances. We work with you to find the most reasonable alternative options that help you get back underway as soon as possible without compromising your safety and your comfort. So those are our safety and comfort are our two utmost goals that we take into consideration for your trip from point A to point B. And we're a 24/7 operation, as I said, so anytime, day or night, if you need any weather-related question answered, you know who to contact. You can definitely reach us at wri@wriwx.com. That's our email that's monitored 24/7. Our phone number is listed here on this slide. You can contact us there, and someone will be there to answer the phone. Our seaweather.net service is a supplemental service, which allows you to be able to plot up weather parameters along a route from point A to point B. Those can include things such as the sea height, the wind speed. You can even overlay those. If you want to make sure you're on the best route for currents, you have that option as well. And so for those of you who are in attendance tonight, what we're going to do, as we have done in webinars in the past, if you are interested in trying out our services, when you do contact us, you can let us know that you learned about WRI through Deb Marler's webinar, the Weather Basics webinar tonight, and we can provide you with a coupon for a complimentary forecast, either in writing or over the phone, and we'll be happy to get you set up and going. So with that in mind, Deb, I am going to turn it back over to you.
There we go. Thank you, Alex. Let's make sure we've got everything going back to, there we go. Thank you, everybody. We have a couple things that I wanted, Alex, if you could, we had a couple questions with regard to hurricanes, because we've been hearing things on the news. And for those of us who are sailing in the Bahamas, the eastern part of the United States, we're hearing things that it's going to be an early hurricane season. And how are we going to know that, Alex? What should we be looking for? What should we really be listening to for valid information?
Thank you for the question, Deb. So one of the first key indicator that hurricane season could be active this year, we're beginning to slowly transition out of an El Nino. The El Nino La Nina effects tends to vary depending on the part of the world you're in. So, for example, because we've been in the midst of an El Nino, the Southwestern Pacific has been quite active. And even areas further east, closer to the French Polynesia, have had some close calls with tropical development. And the last time we saw that was during the previous strong El Nino of the 97-98 year. Now, this El Nino that we're in right now is not as strong as that one was. So we're seeing very good indications that that's going to weaken through the remainder of the spring and transition into perhaps a weak La Nina this summer. Unfortunately, with La Nina, that does not exactly spell the best of news for the Atlantic hurricane season. Some concerns that I have, La Nina tends to weaken the trades and thus the shear. But the problem is that Atlantic sea surface temperatures are still running a good 3 to 4 degrees above average. So you already have one ingredient there that's already, a red flag. And quite frankly, I do think that this year still would have been an active year, even if we held on to a weak El Nino, just simply because of the fact we have those warm sea surface temperatures. But the concern that I have is in the Atlantic and the Caribbean. We're shaping up for a potentially active hurricane season again this year. The peak of the hurricane season occurs in September. And in May, activity is not as common, but you tend to see more development in the Western Caribbean that then lifts into the Gulf of Mexico and can even recurve across Florida and reemerge across open waters of the southeastern United States. But then as we head into the summer months, you begin to see that Cape Verde season start to heat up. And usually those are the ones that we have to be the most concerned about for potential significant impacts across the Caribbean and into Florida and the southeastern US, the Bahamas. So basically what I would say we should be looking at is, expect a potentially early start to the hurricane season in mid to late May or early June. But I don't think it'll truly ramp up until we further progress into the summer, like August, September, and October. Those 3 months in particular are the months that would have me the most concerned, because we'll be moving through the peak of the summer. The sea surface temperatures, which usually experience a lag, they're not going to be the hottest at the peak of the summer months, July. So August, September, and October are the months that I think we need to be paying most special attention to tropical development. And in our supplemental service that I had mentioned, seaweather.net, we do offer daily tropical summaries, letting clients know about the outlook over the next week, any storms that might already have developed, and if we expect any further development, beyond that in the longer range. And we also do provide daily summaries on any existing storms. So definitely contact WRI to get the latest on any tropical development. But I do unfortunately think it's going to be an active year.
Okay. Appreciate that. I think we all do. Yeah. And I have another, I want to address, Lisa, you had indicated, or you were curious if that data was coming from one buoy, and the data that Alex was sharing with you was over a 24-hour period from that one buoy. So yeah, you're actually able to track that and look at the data day to day. So I wanted to make sure that you got that answer. And the other thing that, Alex, I really want you to address for those people who are leaving the United States coastlines and are moving into the Bahamas and then continuing to go south, definitely talk, if you would, just for a minute about the difference in what to expect when you have large land masses like the Dominican Republic, like Puerto Rico, and how it really is impacting where and how people are going to need to sail, and the impact of what you have to deal with during the day versus sailing at night. And if you're not someone who wants to sail at night, that may make it more difficult for you to transit throughout those areas, and the impact of the various equatorial currents that are occurring throughout the Caribbean. So if you could help me out with that, that would be great.
Yeah, so I mean, basically when you have those larger land masses like Hispaniola and Puerto Rico to a lesser extent, but we'll definitely focus on Hispaniola mostly because that's the biggest trouble area. So let's say you're in the Bahamas and you're sailing along. One of the concerns that's very common that can really affect, the day-night sailing is the strength of those east to southeast winds along the north side of Hispaniola. They tend to be stronger during the overnight hours. They're diurnal surges, which basically is a term that's used to describe, the strength of the winds based on the time of day. So they increase at night, but then slightly diminish during the day. Some vessels might prefer, or some sailors might prefer to sail only during the day. Having the knowledge of when these winds are going to be strongest can help them plan accordingly. It can help them to better understand or better plan to get across a given location at a given time. and they can use that to their advantage. If that answers your question.
Yeah. Yeah, I think it does. I just want to make people aware because I think that after we get a little bit complacent after sailing in the Bahamas. Sailing in the Bahamas has some real characteristics that get comfortable for us. And although we get thunderstorms and storms actively, I think it's important to recognize that once we get further south, there's some big changes that occur, and I just want people to recognize that as they're moving. And then I want to make sure that if anyone else has any questions, that they put it in chat as we're wrapping up. So we just have a few more things to cover, and we'll let you guys go. And I would like to just take a minute, first of all, to thank Alex for being here as my partner again. And as always, Alex, great job. I know we did a review. We wanted everybody to have the same playing field. And we added some really good information this time that I think will be helpful. So thank you, Alex.
Thank you, Deb. I've said it before, and maybe it's cliche, but I really appreciate the opportunity to work with you, and you've been a phenomenal partner in this working relationship. So thank you again, and I look forward to future opportunities.
Great, thank you. And if I may, folks, I'd like to just spend a second and just really introduce you to my company. And one of the great things that I am really proud of is I've just launched my on-demand course, Sailing and Boating Basics. And it is really a 365-degree full spectrum, everything that you really, really will need to know to help make the journey easier, make it less costly, and really simplify your learning curve. It is a completion certification course, but most importantly, I put it on demand. I've been working on it to put it in this manner for you since November, and I have completed that, and it is ready, and you can look at it at sailingandboatingllc.com with /basic-courses. I guess I'm not sharing my screen. So boy, shame on me. You didn't get that. Let's see. Well, there we go. Hang on, it figures, right? There we go. So give me 1 second. There we go. Thanks, you guys, for being so patient with me tonight. There we go. And one more thing. Just if you don't know, and we'll go over it here in a second, I have several cruising courses that you can pick from. I do them quarterly, and I do talk very specifically about many of the locations that we have traveled to. And for anyone that you might know who's new to sailing and boating, the basics and intermediate courses are so valuable because they do take you through and teach you the rules, your responsibilities, and we also get you through and get the foundations of chart and chart plotting. And so the other thing that we do is that we are cruising coaches, and we do customized delivery coaching and or remote coaching. So just so you know that those are available to you, if you have any questions that you would like to speak to me about what that entails and what that looks like, you can certainly schedule a time with me at calendly.com/Deb-Marler. And then just again, Alex, as he said, here is his contact information again. And if you guys want to call over to WRI, you can do that and ask them to make sure that you get your sample reports, and that if you're ready to do a trip, that you use them. We have used WRI now for 3 or 4 years, and it's been so useful to us. And then I'm offering you a gift on April 3rd if you would like to join me. And we call it Jump from the Dock to Cruising, but we're really talking about anybody who's having difficulty getting out and getting out to the Bahamas or just cruising. And whether it's short trips, what you might need to know. And we'll be doing that on April 3rd at 7:30 p.m. Eastern time. And that's going to be free to you. And so make sure you jot down this coupon code, and it is WWGIFTSB, all caps. And if anyone needs my email, there it is. It's captain@sailingandboatingllc.com. And I'm going to, one more time, any questions and anything that we need to answer for you that we have not done tonight?